Hello everyone. So in this video we are going to continue with where we ended up yesterday. So as I was discussing yesterday about the update function modules, and before that I also tried to show you a couple of examples by calling a remote function module in different ways, by starting a new task or uh, by calling it in update task or something like that. So we'll go back to our program again and we'll just focus a little bit more on that before we wind up this topic. So now you are aware that you can call a function module, you can call a remote function module from a different target system to your source system. You can call it in background task, you can call it in a new task. So when you call a function module in new task, then you have to receive the results of that function module. So it should be like you have to receive results from function gfm underscore test1. So basically for every new task which you have started by using the extension starting new task, you have to receive the results from the function. So you can see that again we have same thing like importing, changing tables, whatever. And then so it will be like same thing, so you have to enter it manually. So same thing we can copy, like now it will go other way around because now we are importing it back. So this is how we receive the result from a function, especially a remote function. And then again you won't be able to receive the result until you use the statement wait until, let's say, we'll go back to our syntax. Wait until this or wait up to few seconds, something like this. The moment system sees the wait statement, let's say wait up to 10 seconds, so you can easily receive the result from a remote function module which was started in a new task. This one you can see it's in background this way. Yesterday we discussed about it. So this way you can call a function module in background task. I think here they have given some example in which they are calling an RFC function, starting new task, destination in, again as we discussed yesterday, destination, same destination, performing RFC underscore info on end of task. So you have to write a subroutine something like this, and then you have to call that subroutine in which you will receive the result from that function module. So here I have to write, let's say performing get underscore value at end of task. And now these things are not required here because we are passing it here. So we have given it as get underscore value. So like you can see here, form this. So many syntax errors. So this is how we receive the results from a remote function call. So let's just get the concept right. So what it's doing here is that doing it 10 times, that is fine. So every time, like if you see here, I'm hard coding this task 1, but in fact what we can do, every time we can generate a new task name dynamically in the program. So what they are doing, task and then index. So every time the index will be changing by 1, 2, 3, it will keep on adding because we are doing a do and do, which is a loop kind of thing. So it will be like task 1, task 2, task 3. So that way this name will keep on varying, so which actually varies the task name, and then this is okay, this is okay. And when we are calling it here again, this subroutine, so what we are doing, we are using that parameter, that using the task name. So for every task there would be a different call of this subroutine. I hope you are getting me. This might be little little different than a conventional topic. So what is the use of this actually? What is the benefit of this? Now the benefit of this is, I'm going to SM50, and here you can see that I have 6 dialog processes available like this. So what actually I'm trying to say here is that, for example, you have a function module which performs a very complex operation, and then you want to do it let's say for 1000 material. So you have a function module, you have a remote function module which performs a very critical operation for a material, and you want to do it for 1000 material. Now there is one way of doing it, is that you can put a loop and you can call that function module in that. So what will happen, every time it will go and it will call that remote function module every time. But the other efficient way of doing that could be, for example, in this scenario, I know that I have 5 dialog processes available. What I can do, 6 dialog processes available, out of which one will be consumed by default by that program. So we still have 5 work processes left, 5 dialog processes left. let's say I leave one more for anyone else to access it, still I am left with, let's say, 4 dialog processes. So instead of calling that loop for 1000 times, what I can do, I can allocate 250 materials to each dialog process. So it's like parallel processing. So the same function module will be called 4 times by 4 different work processes, which actually will be taken care by the task names. So it's like yesterday I showed you that whenever you use starting new task, it will open a new session. I showed that in debugging mode yesterday. So same way, every new session will consume one task here. And the moment you use the statement receive results, so it will keep on closing one task. So that is the concept here. So here it will keep on tracking that as and when the 10 times is done, it's done for 10 times, they will just close everything. So here they are doing it like this. So that is the concept of parallel processing. You can try to use it in your day-to-day scenario. If anyone is already working on a live example, what you need to do is you need to go and identify the number of free dialog processes available in your system, and then based on that you need to just allocate, you need to keep on calling this, let's say do 4 times. There you saw it was for 10 times. Here we can do 4 times, and then for every do it will just start a new task, and then it will consume one dialog process. So that is how we call a remote function module in different tasks parallelly. Now yesterday we were also talking about an update task and update function module, and I have already explained that it's a part of standard LUW, standard logical unit of work. I have also explained that what is a logical unit of work. So the one thing which you need to understand here is that an update task will be triggered only when there is a commit work happens. So only if there is a commit work happening, then the update task would trigger. So anyway, we'll leave it as it is. Let's see if it really triggers here or not, because we don't have a good example here, but still okay, we are having a breakpoint here. Okay, let's go in debugging mode, give some value here. In the debugging mode you can go to settings, system setting, update setting, everything, save it, F5. Next time if you do F5, it will simply skip this function module. Okay, there is a short dump. Let me just have a look at it. So you can see that it simply skipped that function module. And if I do an F6 here, so you can see that the update function module is triggered now. So what I was trying to explain here is that whenever in your code you see that there is a function module that is called in update task, you cannot debug it directly. You have to go to, in debugging mode, you have to go to settings, display chain setting, and enable this. You have to enable this, otherwise it won't trigger. Now that I have this triggered in update module, I can debug it properly. I have two different sessions available. I can skip this session, this is done, and then I can keep on debugging this session. So I'll explain this more. You just remember the concept. I'll explain this more when I'll discuss output type. I'm not discussing it now because this is actually a part of our forms and all. When we will come here, we will discuss more about it, but then just remember the concept of update function module and update task and standard LUW and all. So now you have seen that how an update task will trigger in runtime. It actually triggers when you call a commit work. Once the commit work is called, the update task will be called after that, which you can debug separately. So we are almost done here. We will talk about lock objects. So let's go back to our reports. I remember in one of the LV reports we were actually saving the data in the database. Yeah, here. Yeah, delete this from this. So okay, so now we are going to discuss about lock objects. So for that I need to go to S11 again. Sorry. This is another problem which keeps on popping up every time, so please bear with me. So this is S11 in SE. Okay, it's not yet open. Yeah, update was terminated. If you received this, it means the update process was not successful. Obviously it was not successful because I simply quit out of that function module, so that update module will not be triggered. So we are going to S11. Here you'll see the lock objects. Now if I do an F4 here, you will see many lock objects provided by SAP. Let's take just one lock object randomly, hit on display. So we have three kind of lock modes here: write lock, read lock, exclusive, not cumulative. So basically write lock is something, it's like I am updating the database for a particular material, so at that time no one else should be able to update that material, and which makes sense also because we expect a consistency in the database, and that's where these lock objects would come into picture. So write lock means no one else should be able to write, but then they will be able to read the data. Read lock means no one else would be able to read the data at that time. Exclusive, not cumulative means it's something like write lock is something like the moment you are done, next person will be able to update it here. But then let me see if there is any documentation available which can give the exact definition. So exclusive is the log data can be read or processed by one user only, means only one user can take care of it. Any other person if tries to access, it will be rejected. So exclusive is this. Shared means several users can read the same data, but only one can edit the data. And then as soon as one is done, next one can do. Exclusive but not cumulative means so exclusive lock can be requested by the same transaction more than once and handled successively. For example, you are making some change in the material, so you can just exclusively lock that material multiple times in the same program. So write lock if let's see if we have a search help. No, we don't have. So anyways, so that is the concept of a lock object. Now whenever we create a lock object, or even SAP provides a lock object, there would be a standard function module generated based on that lock object. So that is why I am taking this topic after discussing the function module. So it will be assigned a default name that enqueue enqueue star and then lock object name star. If I do an F4 here again, so you'll see that there is a lock object with this name. Similarly, there would be a lock object with this name as well. There would be a function module actually with this name as well. So enqueue underscore the lock object name and dequeue underscore the lock object name. So which actually signifies that by calling the function module in your program or in your operation, you can enqueue means enable the lock and dequeue means disable the lock. So what I am trying to say here is, for example, here you are updating VBAK for this VBELN, which means for this particular sales order you are updating the value of test. So before doing this, you might want to put a lock object, you might want to lock this particular sales order so that no one else is going to disturb it. So what we can do, we will create a exclusive lock. Let's say C lock, create this, my mistake. Lock object name should always be starting with EZ. Test lock. Allow RFC means the function module which will be generated would be RFC function module, remote function. Exclusive. Primary table is VBAK. Or in fact, the primary table should be that. Okay, yeah, VBAK is fine here. So you can see by default it takes the key field. Now this particular sales order will be locked for that moment when my operation is going on. So it's activated now. So this is done, and as I said, by default there would be a function module generated for this, so which will be dequeue underscore your lock object and enqueue underscore your lock object. So here what I can do in my program actually, so here what I can do, I can call that function module QEUE. I can call this and open this. Just we need to pass we can just comment these things. VBELN equal to, we know that it's WAVBAK VBELN. And then so if size sub RC is not equal to 0, then it will give a message. Else, let's remove this here, else, which means it's logged, we'll update this commit work, and then we will just release the log, which means DQ. Again you have to do the same thing here, like this, end if. So I hope you are getting my point, what I am trying to say. So before we are updating our table, any database operation, if we are doing it for a particular key field, for example, I am doing it for a particular VBEL, and that is sales order number. So I can log that sales order number for that particular moment, and then I'll wait till the time my operation is not complete. What nonsense is this? Because update, okay, remove this, otherwise it will keep on popping up. Okay, let's go back to our code. So how it works actually, it will go and log that particular sales order number, then it will allow you to update, and then it will release the log so that next person can log it if required. So it's like if I execute this here, ignore this message, not a problem. So 4969, if I take 4969, and if I execute this function module, and again in a new session, I give 4969. So you're seeing that it gives a message, object requested is currently logged by user this. So which means whenever this program will run, the same kind of thing will happen here also. You will get an exception 1. Based on this, this message will automatically give you the details. So this is the concept of logging one field. But then at times you might want to log the whole table also, because you are exclusively doing some operation on that table. Let's say there is a Z table. Okay, I didn't save it last time, so that's the reason. Yeah, so for that there is another way of doing it, is that you can create a new log object, or there is a standard log object provided by SAP. E_tably. So E_tably is basically going to log the whole table. So if I go here NQ_, there would be a function module available for this log object. Same way you can log the whole table, NQ_E_tably. Similarly DQ_E_tably, here you need to provide the table name. So that way it will log the whole table rather than a particular content of that table. So that is the concept of log object Now we will come to job open and job submit. Parallel processing, I have explained the concept. I'm not going to design a full-fledged program here because I don't have that kind of infrastructure. In future I'll see if in real time I'm doing it again, or in any of my team member is doing it. I'll just try to showcase the same example. Now you know update task, this one is postponed till we discuss the forms. Okay, so job open, job submit, and then we are good to move to our next topic, that would be convergence, not interfaces as of now, it's convergence, because once you are clear with this you can easily understand this. And IDOC is a common kind of thing which will be called in both the topics. Then we will move to enhancement. So let's quickly finish this job open, job submit, and job close, and then I have a request from one of my audience that I should give some details on the AMS project. I have already given it in one of the videos, but still I'll just try to give some 10 to 15 minutes time on that. So if you remember during my session on job scheduling, background job and all, yeah, before that one more thing, if you remember in my yesterday's video I told you that how to debug a RFC which is called from a different system. So I told you that you can go to SM50 and then you can select that and you can go to program session, program debug. That is one way of doing it. And if you remember, when I was scheduling the job via SM37, I showcased that you can debug a job by doing a JDBG there. Same way, if the job is running, you can select that job here. So that will be actually here in the background mode. You can again do the same thing, but the difference here is that if you do this, so it will start debugging only from the place where the program is currently processing the logic. So if I talk about a normal job which is in scheduled mode, I think there will be so many jobs. Oh god, should have restricted the selection. So whenever there is a scheduled job, I can do this and I can do a JDBG, and if I hit enter it will take me into debugging mode. But then if there is a job which is already running, so for example this job, let's say this job, if we release it, something like that, so that job will, obviously not this job, it cannot be done now. So whenever there is a job that is released and it's in active stage, that will appear here. You can select that job and debug it, but the only thing it will start debugging from the place where the system is currently processing the code. While if you do a JDBG here for a scheduled job, it will do it from scratch. Now if you have gone through my earlier video of job scheduling, you would have seen that I used two transactions, SM36 and SM37. SM36 is basically to create the job, SM37 is to monitor the job. And then the other way of scheduling a job is that you can directly run the program and you can execute in background. That is also as good as SM36. It will schedule a job with this name. Now we are coming to another concept. For example, there is a very big program that is going on, and in between you want to run some transaction in the background. Obviously if you do something in background, you are not entitled to get a result out of it because it will take its own time. So but still if you want to do it, so SAP has provided 3 different function modules. job open. So it's as good as creating a job, that's it. So let's see if any example is available. So I'll just explain that example because I don't want to write a code now for this. It's a simple task. So you'll see it's being used at so many places. So we'll take a Z program. So here what they are doing, job open. So you give the job name and job number. Job number you can give as 1. Job name is the program name, like this program name. And submit means submit the program name via job, this job name, number, this job number, and return. So it will create. So this basically here you are assigning the name to a job and a number. Here you are triggering that job in SM36 and job close. Here you can see if you call this function module, job number, job name, and then okay, let's try to let's try to showcase this job. Don't go with the spelling, let it be wrong. So I'm not doing anything special till now, just created a new program and then enabling the includes, like I have been, and this one is a new headache I have created for me. By enabling the update till the time I don't exit, it will keep on bugging me. So I come here, every time if I save anything, this update will trigger. My god. So I can call the function module job open, and like in this example program, I can give a job name and a job number. Let's hard code it for now. Job name equal to this, job count equal to 1, So this way I just gave the job name. Next one here, they have used this statement submit this and return. Something like this. And then job close. So job count equal to v underscore count, job name equal to same job name. Now one more thing you have to understand here is that we have a parameter called streamed. If streamed equal to x means job will be released immediately, otherwise it will still be in the scheduled mode. Like this. So now if I run this program, so if I run this program now, basically it will schedule a job in, that would be visible in SM37. Okay, let's just wait, it's still working. I hope it's not hanged this time. Looks like it's gone. I'll just pause the session for time being. I'll just fix. So the system has hanged again. Okay, it came back. Let's see if it goes through. Don't know what happened to this. Okay, sorry for that. So we'll complete my session at this point itself today, because there is some issue has come in the system. So tomorrow in the first 15 minutes I'll discuss about the AMS projects, because someone has requested me for the same, and then I'll continue with the interfaces. Basically, not the interfaces, in fact the convergence. So tomorrow onwards we will start working on convergence, and then slowly we will move towards interfaces and then forms and then enhancement. So that way it will complete all the RICEF. After that we will move towards object oriented and then workflow, and at the end we will work on WebDin Pro. So my apologies, this one is not going through today. So we'll just, but then you should get the concept that how we can schedule a job programmatically by using the function modules: job open, a submit statement, and then job close, or job open and a job function, job submit function module, and then job close function module. So thanks for your time, and then see you again tomorrow.